Hi everyone, welcome to Trigonometry. Today we explore lesson 9, Trigonometric Identities, part 1. Number 1, basic identities. We have quotient identity, that is tangent is sine over cosine, and cotangent is cosine over sine. These identity come from basic definition of tangent and cotangent. We also have a reciprocal identity, that is 1 over sine is cosecant. 1 over cosine is secant. 1 over tangent is cotangent. 1 over cosecant is sine. 1 over secant is cosine. 1 over cotangent is tangent. From the previous video, we have a cofunction identities and negative angle identities. For cofunction identities, sine of pi of 2 minus theta is cosine of theta. Cosine of pi of 2 minus theta is sine theta, and it is true for the angle theta between 0 and pi of 2. Negative angle identities. Sine of negative angle is negative sine of the angle, and cosine of negative angle is cosine of the angle. Đấy, pretty cool. Next, Pythagorean identities. Well, we can figure some of them out by draw the right triangle. This is the angle theta. Adjacent is x, opposite is y, hypotenuse r. We know that sine square plus cosine square is y over r square. Cosine x over r square. We have y square over r square plus x square over r square, common in the denominator. So x square plus y square over r square, and x square plus y square is exactly r square. So this from the Pythagorean theorem. And therefore, sine square plus cosine square is 1. Very nice Pythagorean identity. From this identity, we can have 2 more. Sine square plus cosine square equal 1. Divide by sine square. From here, we have 1 plus cotangent square equal cosecant square. Do the same trick. Sine square plus cosine square equal 1. Divide by cosine square instead. And we have tangent square plus 1 equal secant square. And these are the three Pythagorean identities. To simplify trigonometric expression, a cosecant x minus cotangent x over secant x minus 1. Best way to simplify is convert each trigonometric term into sine cosine. So cosecant is 1 over sine, cotangent is cosine over sine, secant is 1 over cosine, and number 1 is cosine over cosine, same denominator. From there, we can do a common denominator. 1 minus cosine over sine divide by 1 minus cosine over cosine, and then use the property of division. 1 minus cosine over sine multiplied to the flip of the second fraction, cosine over 1 minus cosine. Look at the 1 minus cosine cancel out. We have cosine over sine, which is cotangent. Very nice. In the second one, cosecant x cosine square x plus sine x. We can convert cosecant into 1 over sine. 1 over sine times cosine square plus sine. Get the common denominator, so multiply sine by sine x over sine x. And from there, we have a cosine square plus sine square over the common denominator, sine x. Cosine square plus sine square is 1, Pythagorean identity. 1 over sine x, no, 1 over sine is cosecant. Very cool. Okay, in C, when you look at this one, do not FOIL, use identity. 1 minus cosine square multiplied to 1 plus cotangent square. 1 minus cosine square is sine square, Pythagorean identity. 1 plus cotangent square is cosecant square. And then cosecant is 1 over sine. So cosecant square is 1 over sine square. Sine square times 1 over sine square. And then from there, the sine square cancel out. So we just have 1. Super cool. And that is what it meant by simplify trigonometric expression. We can also verify identities using basic identities. A cosine x over 1 minus sine x equals secant x plus tangent x. In order to verify identities such as this, look for one side of the equation that is easier to work with and work it out until we get to the other side. Now, the left side seems to be easier. First, cosine x over 1 minus sine x. We can multiply by the conjugate, 1 plus sine x over 1 plus sine x, and work out the left side. So we have a cosine x times 1 plus sine x over 1 square minus sine square. Oh, 1 minus sine square is cosine square. So we have a cosine x 1 plus sine x over cosine square. And then the cosine square cancel out, give us 1 copy of the cosine x in the denominator. From here, we can split this out. 1 over cosine x plus sine x over cosine x, and ta-da, 1 over cosine secant. Sine over cosine is tangent, and that is it. We have reached the right side of the equation. So this is what it means to verify identities. In B, sine x plus cosine x squared, what we need to do is FOIL it out. Sine x plus cosine x times sine x plus cosine x, and hopefully when we simplify, it will give us exactly the right side. 1 plus 2 sine x cosine x. Sine times sine square. Sine times cosine is sine cosine. And cosine times sine is also sine cosine. So 2 copy of sine x cosine x. Cosine times cosine is cosine square. Now we can move the sine square next to the cosine square. And sine square plus cosine square is 1. It's Pythagorean identity. So plus 2 sine x cosine x. That is it. We got the identity. Pretty cool, huh? 2 more. In C, 1 plus secant square over 1 plus tangent square. Just used one identity, guys. 1 plus secant square, we don't have any identity for that one. 1 plus tangent square, yes, Pythagorean identity. So it is easier to work with the left side and show that the quotient is exactly 1 plus cosine square. 1 plus secant square over, well, 1 plus tangent square, secant square. And then from here, split the fraction into 1 over secant square plus secant square over secant square. 1 over secant square is cosine square. Secant divided by secant is 1. That is it. We show that the left side is exactly the right side. D, 1 over 1 minus sine x minus 1 over 1 plus sine x equal to secant x tangent x. If you look up this identity, the right side is similar. The left side is a little more difficult, but we can simplify the left side. So work with the side that we can simplify. 1 over 1 minus sine x minus 1 over 1 plus sine x. The least common denominator, or LCD, is 1 minus sine x times 1 plus sine x. So we're going to multiply the first fraction by 1 plus sine x over 1 plus sine x. 1 over 1 minus sine x times 1 plus sine x over 1 plus sine x. And the second fraction, 1 over 1 plus sine x by 1 minus sine x over 1 minus sine x. Okay. We have 1 plus sine x minus 1 minus sine x over the common denominator. 1 square minus sine square x. Well, look at what we have here. 1 plus sine x distribute -1 plus sine x over 1 minus sine square is cosine square. And 1 is gone, sine plus sine is 2 sine x over cosine square. We can use this as 2 sine x over cosine x times cosine x and split this out. So I have 2 times sine x over cosine x times 1 over cosine x. Yay! Look at what we have here. 2 tangent x secant x. It is the same as 2 secant x tangent x, because we can move the term around in a multiplication. That is it. It looks exactly like the right side. So we just verify this identity. Thank you for watching. I hope you found the content useful. Please like, subscribe, help the channel grow. I will see you in the next video.